So the thing is, the problem which we are going to try, like we're gonna solve, is being already articulated really well by the other team. So I'm gonna quickly skip over the problem statement and the awesome potential of the drone industry in agriculture. So this is the motivation and background for like all these things. So we have like billions of dollars saved by drones, and we got like a cool footage for. We tried to get the data for like the tomato industry, and we tried our best to collect the data. Oh my God! Okay, let me show you that later. We only got like just grass instead of tomatoes because the season is not like ripe. That's what that was. That's one of the challenge. We didn't have any data. We thought of using all the cool artificial neural networks, computer vision, but we didn't have any data, so we had to follow the textbook style of solving the problem. So we did it. We tried to solve it, and we got some decent results. So we are able to predict a ripeness score of the tomatoes. So what you see here is the fully processed image. This is the actual image which will be taken from the drone, and this is the fully processed image. And after the processed image, we take the average of the, and we crop those components of tomatoes, and we take average, and we give like a ripeness score based on the ripeness score and the threshold. This threshold might vary based on season, temperature, like the time, temperature, light, everything else as well. So we take all those data and vary that. And acknowledgements, thanks for Aaron for providing us some grass footage. We actually like contacted many people, went to some farms, didn't find anything. And also, let me show you some more demos. Like we did a bunch of research, and also yeah, so let me show you quickly what I have done. So we have followed all the textbook style algorithms. We have manually tuned the parameters. We have tried to use different images for robustness. We have tried all the things. So finally what worked is segmentation after turning that into HSV scale, and then clustering using k-means, and then using the second maximum cluster and removing it from the first maximum cluster gives us the actual tomatoes, which is the cool algorithm I designed in like one day. Cool. This is by the way, maybe this can be designed in 2001. These are all the algorithms before that. But we don't have data, so we had to use that. And we also, my team also built an M2X API, but the problem with that was it couldn't stream data, so we had to decode it in a string, and it had to reduce the drone imagery, which is 1080p, to 48 by 48, which is crazy, but yeah, we did that, and all the code is available in GitHub. Please look into it.